Okay, good morning. So this would be now the last video on the paper 1 of May-June 2021. Okay, this is the last question. If I had made any mistakes in the paper, please contact me on this number here. Or if I've explained something wrong as well, you can refer back to this number here. Otherwise, if there's anything easier method to apply to a given sum, feel free to contact me. Okay. These videos are free. So, in question 11.3, there was, when I initially looked at the sum, okay, I had a completely wrong understanding of this here. So a fellow colleague at the school in our district helped me out. Okay, so I'll try and explain to you the way I understand it now to be. Alright. So in 11.3.1, we are told that a 3-digit number is made up by using 3 randomly selected digits from 0 to 10. No digits may be repeated. So if that is the case, we can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, not 10, 9. So if you count those digits, okay, there are 10 digits in total. Okay? So the question says determine the total number of possible 3-digit number greater than 100 that can be formed. A 3-digit number that is greater than 100 that can be formed. Okay? So if you consider now the numbers that is greater than 100, from 1 to 9, I have 9 options. From 1 to 9. Remember, we are omitting 0 here. So the number must be greater than 0. Alright. Then in the next number, the next category here, 0 is brought back into this. So in other words, I have 10 numbers to choose from. However, numbers are not repeated. My numbers may not be repeated. So whatever number I got in the first, on the first bit, on the first account, I can't use again. Which means to say, out of 10, I have now again 9 options. Okay? So the number has to be greater than 100. So the options we have here is then has to be 8. Okay. So you put that in the calculator, it's going to be 9 times 9 times 8. It gives you 648 of such options, of such combinations of numbers that can be formed. Okay. Again, if I'm understanding it wrong, please let me know on this number. Okay. Right, let's look at the last question in the sum and in the paper. Of course, is something again to think about. So in 11.3.2, we are told determine the total number of possible 3-digit numbers, both even and greater than 600. So the condition is it must be even and must be greater than 600. That can be formed. So if you're looking at 3-digit numbers, there's a couple of things we need to consider. So we'll break it up into the cases we find ourselves in. In the first case, if you consider a 3-digit number, if we start off with the fact that it has to be an even number. Remember, for this year, it can only be 0 in the last place. It can be 0, 2, and 4. Alright. if we consider the second, this is now the second option, but we will sort out, so we'll call this next for now. So I could have put 6 here, and I could have put 8 there, not so. However, I'm considering these numbers, which is 6, 7, 8, 9. Okay? So if I were to consider 6 and 7 here, 6 and 8 here, then I can't consider 6 and 8 in the final, in the last bit. Okay? So what happens is, take this away, so I put 6 and 8 is out. So how many options do I have in the last case? 3. In the next one I have 1, 2, 3, 4 options. Since I've got, I got 10 digits to choose from, so this is my last number to be placed is going to be, I've counted for one there, I've counted for another, so it gives me 8 left to choose from for the middle number. Okay, so that's case 1. So considering this information here, we got 4 times 8 times 3 such cases, or such combinations, sorry. Let's look at case 2. In case 2, again, it's a 3-digit number. If we start off by saying the last number, we're going to consider to be a 6. Okay, this is the last number. Remember, this is also the last. No, we're just considering the last in the first case. So the last number is being 6. And of course, in the next case, your last number is going to be a 8. Alright. So if that is the case, the last number being 6, so how many options do I have there? 1. So let's account for the next bit. So the options, this could be the 7, 8, or 9. Why don't I put 6 here? Because I'm accounting for 6 in the last bit. Okay? So how many options do I have there? I have 3 options. Okay? Which again gives me, out of the 10 numbers, I chose 1 there, so I have 9 options left. Then I got 8 options after placing that value, which then gives me 8 in total. So in other words, for case 2, there are 3 times 8 times 1 such combinations that can occur. Okay? Now for case 3, again 3-digit number, we're starting off as the last number being an 8. Okay, last number being an 8. So how many options do I have? There's only 1 8. This is the next number we're placing. Now remember, it can be a 6, a 7, or a 9. 6, 7, or 9. Okay, so how many options are there? 3. So again, there's 10 numbers to choose from. I placed 1, 2, so I'm left with 8. So in other words, there are 3 times 8 times 1 such combinations that could happen. So now in total, we add all 3 cases up together. So the first case being 4 times 8 times 3, plus the second case, which is 3 times 8 times 1, plus the third case, is 3 times 8 times 1. So in other words, 3 times 8 times 1 plus 3 times 8 times 1 plus 4 times 8 times 3. So in total there are 144 such combinations that can be made up given that information in the sum. Okay.